this video, what I'm going to teach you to do is find what we call an explicit formula. An explicit formula takes any two terms within the sequence, and we rewrite the formula for it to find any other term within the sequence. So here I'm giving you A1, and that's negative 14, and also A9, which is positive 18. And I want you to find the value of A20, which is further down the line. Well, the first thing we have to do is find a common difference. And here's a concept that you've probably done before. You didn't realize you did it. And this is a concept that's based around slope. Because an arithmetic sequence is really just a line. It's in a sequence form. Because remember, in a line, the slope makes the line increase by the same amount every time, or your common difference. And just like that here in an arithmetic sequence, we're increasing by the same amount every time. So we need to find a common difference. So to find that common difference, we know a few things already. We know, for instance, that your first term is negative 14. We also know that your ninth term is equal to 18. And the big thing we know is that it's linear, or that it's increasing by the same amount every time. So because of that, we can actually find D using slope. And remember, the slope D, or the slope of a line, is the change in x, the change in y over the change in x. So change in y, or delta y over delta x. Well, in our case, ours is going to be the change in the value, which these are the values right here. The change in those values over the change in the position. And our positions are here, the smaller numbers. So in this case, our slope would be equal to 18 minus a negative 14. And we're going to divide that by the position changes, which changes from 9 minus 1. And so when we do this, 18 minus a negative 14, remember, two negatives together becomes a positive. So that's 18 plus 14, which is just 32. And that's divided by 9 minus 1, which is just 8. So when we do 32 divided by 8, we get 4. So our common difference, or the change in the value over the change in the position, is equal to 4. So now we know D equals 4. We also know A1 already, because we found it right here. It was given to us. That's equal to negative 14. So A1 is equal to a negative 14. And we know our formula says that AN is equal to A1 plus N minus 1 times D. Well, look what we have. We have D, we have A1, and we're trying to find AN for A20. So we want to find A20. So that means that my N is equal to 20. So A20 is equal to A1, negative 14, plus N, which is 20, minus 1, times D, and we found our difference to be 4. And again, now we just work this. So this will be A20 is equal to negative 14. 20 minus 1 is 19. So it'll be plus 19 times 4. A20 is equal to negative 14 plus 19 times 4 is 76. And if we subtract negative 14 plus 76, we're going to get 62. And so that means in A20, there's a total of 62. And we could actually count this out starting at negative 14 and verify that. Because we go negative 14 and we add 4, and we get to negative 14, add 4, you get to negative 10. Then you add 4 and get to negative 6, then add 4 and get to negative 2, then add 4 and get to positive 2. If you keep doing that, you'd have to do it 20 times. But if you got to that 20th number, at the 20th term, it should be equal to 62.